this lecture, I am going to present what are the basic objectives of structural analysis and what are the different methods used for the analysis of statically indeterminate structures. First, coming to what is the structural analysis and what are the objectives of the structural analysis. Structural analysis deals with the mechanism of degeneration of load applied on the system into local element forces using various theories. It also deals with the computation of deformations of these members suffer under the action of the induced forces. In structural analysis, the state of stress or deformation is generally described in terms of forces and displacements at selected points known as nodes. The nodes are also called the joints, and the nodes are usually the end of the members. The structural members are known as the element of the structure. The state of stress or deformation within the structural element can be completely defined in terms of forces or displacements at the nodes of the element, provided the relationships between the force and displacements are established. Corresponding to the basic concept of force and displacements, there are two important physical requirements which must be satisfied in a structural analysis. The first requirement is termed the structure as a whole, and every part of it must be in equilibrium under the action of the system of forces. The second requirement is termed continuity or compatibility conditions. In second requirement, that the component parts of a structure must deform in a compatible way, that is, the parts must fit together without discontinuity at all stages of the loading. Then coming to what is the force displacement relationships. The force displacement relationships for the structural elements are an important part of the process of structural analysis. They incorporate element properties in the formulation of a mathematical model of the structure. The force displacement relationships in a structure are generally expressed in a matrix form. The individual force displacement relationships for structural members are combined to produce a force displacement relationship for the complete structure. There are two basic forms of force displacement relationship. Then coming to the first type of relationship, the force displacement relationships for a structural element are expressed as P is equal to K into delta. Where P and delta are the column matrix which contain the end forces and displacement respectively, and K is the stiffness matrix of the element, since it contains end forces corresponding to unit values of the end displacements. So this is the first type of relationships used in the structural analysis. Then coming to the second type of relationship. So in second type of force displacement relationship for structural element expressed in the form delta is equal to F into P, where delta and P is the column matrix. It contains the end displacement and the end forces, and the F is the flexibility matrix of the element, since it expresses the end displacement corresponding to the unit values of the end forces. Then what is the relationship between the stiffness matrix and the flexibility matrix? So here we know P is equal to K into delta, and where delta is equal to F into P. So after putting the delta value here, F into P, so the expression becomes Kf P is equal to Kfp. So here K and F, K is the stiffness matrix and F is the flexibility matrix. Multiplication of these two matrices is the unit matrix. Then P is equal to unit matrix I into P, and here the stiffness matrix is equal to the inverse of the flexibility matrix. Here the flexibility matrix and the stiffness matrix both are inverse to each other. So F is equal to K inverse. Then coming to what are the different methods used for the analysis of statically indeterminate structures. So there are two distinct methods of analysis for statically indeterminate structures depending on how the force displacement relations, equilibrium equations and the compatibility conditions are satisfied. There are two methods. The first method is force method and the second method is displacement method. The force method is also known as flexibility method or compatibility method, and the displacement method is also known as stiffness method or equilibrium method. So first coming to the force method. In analysis of statically indeterminate structures by force method, the structure is reduced to a statically determinate structure by eliminating a sufficient number of pre-selected redundant reactions and internal forces to enable the determination of remaining support reactions and internal forces from the consideration of statically equilibrium. So in this method, first you have to choose the degree of static indeterminacy, then we have to choose the redundant forces or reactions. Then after eliminating the redundant reactions or forces, the structure is enabled to determination of remaining support reactions and internal forces from the consideration of statically equilibrium. The choice of the forces to be treated as primary unknown or redundant is made in such a way that equilibrium is satisfied. The magnitude of these forces are then determined from the solution of equations obtained from the requirements of continuity or compatibility of displacements of elements at each node written in terms of redundant and flexibility coefficients using displacement force relations. So this is the example of the force method. So here this is the statically indeterminate frame. So this is support A, this is support D. Support A is fixed end and support D is fixed end. So at support A there are 3 reaction components, and at support D there are also 3 reaction components. This is the indeterminate frame, and the degree of static indeterminacy is equal to 3 because there are 6 reaction components but 3 static equilibrium equations are available. So here the degree of static indeterminacy is equal to r minus 3, that is 6 minus 3 is equal to 3. So the degree of static indeterminacy of this frame is equal to 3. So here the frame which is converted to the determinate frame by reducing the number of reaction components 6 to 3. The 6 reaction components can be reduced to 3 reaction components by choosing 3 redundants. The redundant we can choose in 2 ways. So in first type, this is the first type of determinate structure, and this is the second type of determinate structure. In first type of determinate structure, and the structure is determinate by having one of the supports as hinge support and another support as a roller support. So here you see, so this is converted to hinge support, and here the fixed support is converted to roller support. So here there are two reaction components, and here there is one reaction component, so total three reaction components. Then another three reactions are the redundant. Similarly, this is the second type of determinant structure. Here this end remain as usual fixed, and this end totally removed from the structure. So here this becomes the cantilever, one end is fixed and other end is free. So this also become the statically determinant frame, second type of frame. So in second type of determinant frame, by keeping one support fixed and other support removed entirely here. Both are the determinant structures. You can go for the both type of determinant structure for analysis of the structure by force method. So releasing a structure in this way would result in displacements. These displacements may be calculated by analyzing the released practical determinant structure. The force system required to eliminate them is then obtained, that is, compatibility of displacement condition is satisfied. After the redundant have been computed, the stress and strains throughout the structure can be found from equilibrium equations and stress-strain relations. The force methods are nowadays seldom used due to their greater complexity compared to stiffness method. So these are the different classical force methods: the consistent deformation method, then the Castigliano's theorem of minimum strain energy or method of least work, then the theorem of three moments, then column analogy method, then elastic center method, then Maxwell-Moore equations method. These are the different force methods used to analysis the indeterminate structures. Then coming to the displacement methods. The displacement method of analysis is also called the stiffness method. Treats the displacements at the specific points in the structure are the primary unknowns. The essence of the method lies in establishing a relationship between forces applied at certain nodes of the structure and the displacements occurring there. Generally, in this method, the procedure requires a structure to be divided into a number of elements for each of which force displacement relationships are formulated. Then the equilibrium equations governing the behavior of the assembled system are obtained simply by summing all the forces acting at each joint and equating the sum to the external force. For the assembled system, the joint displacements become the primary unknown, and by imposing sufficient boundary restraint on the system, these equations can readily be solved. After the unknown displacements have been computed, stress and strain throughout the structure can be determined. And these are the different classical displacement methods of analysis: slope deflection method, moment distribution method, Kani's method, direct stiffness method, finite element method, minimum potential energy method. These are the different displacement methods are used for the analysis of statically and kinematically indeterminate structures. Then what is the comparison between the flexibility and stiffness method? In the flexibility method, the structure to be reduced to a statically determinate state by inserting release. It requires some judgment during the analysis of the structure. Whereas in the stiffness method, the structure is idealized for the problem the unknowns are automatically chosen. Hence, this method does not require such judgments to be made and is therefore particularly suitable for automatic computation. In the flexibility method, the degree of statical indeterminacy of a structure is required for making the appropriate number of release. Whereas in the stiffness method, the kinematic indeterminacy of a structure is needed to determine the number of constraints that must be applied to render the structure kinematically determinate. In force methods or flexibility method, the number of unknowns equals the degree of static indeterminacy, whereas in the displacement methods, the number of unknowns equals the degree of freedom of displacement at nodes. The practical application of flexibility and stiffness methods is generally computer based. They are fundamental to conventional hand method of analysis. Both the methods are based on the relationships between the force and corresponding displacements. So these are the comparison between the flexibility and the stiffness method. Now all are clear. What is the basic concept of structural analysis and what are the different methods used for the analysis of statically indeterminate structures? That is the force method and the displacement method. And what are the different force methods and different displacement methods? Then what is the comparison between the force method and the displacement methods?